Well, hello, here I am again, Professor Stephen Neshaba, and I'm on part 2 of this computational exercise. Now, where we left off last time was that at the very beginning of our titration, before we've added any sodium hydroxide, we figured that we had a pH of 2.96, and so I've set up some columns here that we're gonna use, and you should perhaps set up those too, because we're gonna add to this. Okay, well now assuming you're back, the idea is that we're going to add in some more volumes that we're going to add to our titration curve. Let me see if I can pick up what it looks like. So this is the sort of curve that we're trying to make here, and so I'm going to just start to work on that. And let's see. So I'm going to put in say 1 milliliter, that's what we're going to start with. And let's see where else. I want to calculate the pH there, but in order to do that, I've got to figure out a few things. One of them will be the pKa of my acid, and you know how to do that. I think it's based on the Ka, so maybe you should try to do that. Okay, I think what I should do is say equal minus the log of the Ka, which is that value right there. And okay, so there's a pKa of 5. Now, how about the next item here? I need to find the equivalence volume, the volume of sodium hydroxide I need to titrate. Now, that must be equal to the number of moles and of the analyte solution. That's this quantity here, divided by the concentration of the titrant that I need to use to neutralize it. If you want to give that a try. All right, let's see how I'm going to do. I'm going to say equals the number of, in this case, the millimoles of the analyte divided by the concentration of the analyte. And let's see if that gives me a number. Yep, that gives me 30, and the units would have to be 30 mils. So it's 30 mils that I need to that's the amount of titrant I'll need to add. So I'm going to know that I'll have to go all the way down to, I want to stop one shy of that, so this will eventually get filled down to 29. But let's see, this pH row I'm going to skip for right now, because the next column I want to calculate is the fraction of HA that has been converted to A minus after I've added 1 mil, and I think that we if you followed in lecture, what we need to do there is that fraction, it must be equal to, well, it's related to this volume out of 30. So if you want to give that a try, go ahead. Okay, I think that fraction would have to be equal to the volume that I've added so far, divided by the, well, the total volume that I need to titrate. Okay, and so it's that number there. Now, because I'm anticipating a fill down, I'm going to put that as $B $7. All right, and let's just see. I'm going to start a fill down right there. All right, that's looking pretty good to me. What about 1 minus F? That's the fraction of HA that's remaining. If you want, you can try to do that. All right, well, this is pretty easy. I think that's going to be 1 minus F. That's straightforward. And well, I may as well work on this one. That's the ratio of A minus to HA. That's our the ratio that we talked about. And let's see, that's going to be equal to F divided by 1 minus F. Okay, and I think that looks good. And okay, I think that's all looking pretty good. So the next thing I'm going to do is I'll just, oh, well, I may as well calculate a pH on that. How do I get the pH? Well, I'm going to use the Henderson-Hasselbalch equation, if you want to give that a try. Okay, here's the Henderson-Hasselbalch equation for the pH. It's equal to the pKa, which is that number 5, plus the log of the acid-base ratio, and that's equal to that value. Okay, so I think we're doing okay there. And I'm going to fill that down. Oops, oh, I didn't, what I needed to do was fix the B6 to $B $6 so that didn't fall down. And let's see. Oh, that's looking pretty good to me. Now, the last thing that I need to do is just bring this all the way down to 29. I think I'm going to fill this one down first so I can see the numbers. 28, there we go, 28, 29. And now I'm going to grab these guys and go to the lower right and fill those down. And there we go. And I think that that's looking pretty good. I'm just going to take us back to this my cartoon figure here. The one thing I do want to point out to you is that if we have an equivalence volume of 30, that means the half equivalence volume would be 15 milliliters, and I'm just checking to make sure that the pH really does equal the pKa at that point. And it does, and so that's why I've drawn it here. At the half equivalence point, the curve, the pH equals 5, and there I've indicated here that the equivalence volume is 30 mils.